All right, cool. We're back. Given a binary tree, check whether it is symmetrical. For example, this binary tree is symmetrical. Okay. All right, first thing I'm thinking of is, let me get a charger. If we basically traverse the left and right in the exact same way, using any order, then well, first of all, if not root, return false. Then yeah, it doesn't really matter which order we use, right? So we can just say, let's try if we, for example, in order, post order, or what's the other one? Pre-order it, the left and right subtree. All we gotta do is say that if they're not equal, then. So we have, if not root, return false. And we have, let's make an inner function for this real quick. Def symmetry and say something like, actually we could put this. Yeah, actually, yeah, we can say, okay, so def symmetric feed in the node. This would be like the left and right. So we can say something like, if node.val sorry, we can say return node.val. No. Symmetric feed in the left, symmetric feed in the right. Left, right, the left and the right. Ooh, if not, no, return false. Return the left and the right. Should wait. If not node, return false. Return symmetric node dot left, symmetric node dot right. Left equals make like a list to store, generate to store the left and right subtrees, and say, so this would be like, and then return node.val, and then we can say like sim node.left, say left.append. Does this even make sense? Can you do this? Is this even possible? Did I say left? Yeah, left.append sim node.left, right.append sim node.right, print left and right. Name node is not defined. Oh, oops. Root. 2222. Your input. Okay, so return the value, but it needs to symmetrically. So what if I did this? Does this make any sense? Oh, wait a minute. No. Okay. No, actually no. We want to, we go left, so we look at the left, we look at the right. Look at the left, look at the right. Look at the left, look at the right. We want to take the node value. So essentially we're saying we're looking at the left, we're looking at the right, then we're doing our, thing with the node's value. So this is a post order traversal. So it's, the idea is to do look at 2, then do something with 1, look at 3, look at 4. So we're going down the left subtree. So look at 3, look at 4, look at 2, then look at 3, then look at 4. When you get to null, so hang on. Symmetric node dot left, symmetric node dot right. If not known, well, this isn't needed. Def sim node, if not node, return false. Sim node dot left, sim node dot right, node dot left. Well, not return false. Return return false actually. Well, actually, yeah, okay. Sim node dot left, sim node dot right, node dot left. Node dot value, node dot value, node dot value, node dot value, node dot value. Oh yeah, we got a parameter here. Call it output, for example, and then say output dot append node dot value, and then we have output here. Then we can return output. Actually, output equals that. So when we feed in root dot left, we can then feed in left, and feed in right. So output dot append return output. 342. return left and right. Unsupported. Oh, and true. True. We feed it in node root dot right, root dot left. Print left and right. Same node dot left. Return output. Return output, Output dot append. Output dot append node dot val. In this case, we're feeding left and right, so this should work, right? 32 none, 32 none, 32 none, 32 none. It's saying it's true for some reason. How would that be true? 3 2 3 2 none 3. So 3 2. This is a post order. 3. Well, the thing happens after, so we have no dot val. So sorry. We could do the. We look at the left. We look at the right. You see, there's nothing here. We look at the right. Actually, let me hit up auto draw. See what kind of logic I'm just trying to do here. So we have a tree. We have a tree 1 2 2. So we have 1. Then we have 2 2. Then we got 3. Then we got 3. This is null. This is null. This is not symmetric. So we have 1 2 3 1 2 3. And the idea. So if we look at what was I doing here? I was doing post order. What if I do it? What if I do pre-order actually? Still true. Okay. So I don't think I'm doing a pre-order traversal here. Actually, no. Wait. If we did an in-order traversal, left, up, left, up. Oh, of course. Of course. I mean, if we did a doesn't matter what traversal we do here, we can see it's always going to be the same post-order traverse because the fuck, of course it'll be the same value. The point is that the yeah, I see. The point is that the left value in here, it gets not symmetric if you overlap them. Is the point? I see. So if you flipped 2 and 2 on each other, so you okay. I get it. Okay. So this is not the way to do it. For that to be symmetric, the 3 would have to be on over this side. So what if so this is a pre-order traversal. So you're saying that if we have a pre-order traversal, and an in-order traversal, it's a 3 2 4 3 2 4 4 2 3 3 2 4 4 2 3 2 1 2 2 1 2. So I think you could say if the in order traversal equals the op. Oh, okay, wait a minute. Oh, no, wait. To see if it's symmetric, you don't need two of these, right? You just need to say you would just need one of these, right? And you could say, so then if I printed result, and then, you know, the idea is that if it equals the reverse of itself, it should be symmetrical, right? Invalid syntax. Return result equals result. Oh. Left is not defined. Root dot left. Oh. Whoopsie, whoopsie, whoopsie. 2, 3, none. 2, 3, none. Two, three, none. What the fuck? 2, 3, none. I'll put out a pen now. No, don't allow. If not, no, return false. Symmetric root dot. Oh, I'm not going through the right. I'm not. Oh no, sorry. We just need to go through the whole thing. One, 2, 3. How the fuck is this printing out true? Huh? This is not equal to each other. The reverse of that is not equal to each other. What? What? False. Wait, if you're giving this output, tell me this is supposed to be true. How the fuck is this? Where's this none coming from? There's no none in here. What? None. Why is none being appended? What the fuck is going on? What the fuck is going on? If not, no, return false. Hang on. If not, return. Actually, should I even be returning false? Or should I just be returning, like, just return? Return false, like 1, 2, 3, 4, 5. What the fuck? You can see my idea, though. The idea is to essentially just traverse the tree. Oh, wait a minute. Should I be? I'm doing a depth first search. Should I do a breadth first search? Let me see. If I were to breadth first search this level, I would have these two are the same. If I breadth first search this level, so you're saying a half of this should be equal to half of this. Well, that wouldn't work, because if I were to even say null 3, that would say that's symmetrical. So what needs to happen here is that you have to say that you have to kind of go backwards, reverse it. You have to say like the 3 has to equal to 3 here. So, but I'm depth first searching this though. So I'm going boom. Maybe depth first search is not the way. If I were to breadth first search this, I would be saying 1, 2, 1, 2. So I'd be saying 2 equals 2. I'd then be saying that the position minus 1 here in this level is equal to the position 0. Then the position 1 is equal to the position minus 2. So I kind of have to like go right? I have to say that the reverse half is equal to the non-reversed first part, right? Like in this tree here, so if I were to level traverse this, I would be saying that 2, 2. I'm saying 2, 2 as in the position -1 in the array and 0 are equal to each other. But then here where we have, let's say, null, let's just say it's 0 and 0, we have 0, 3, 0, 3. Essentially, I'm saying that for this to be symmetrical, this has to equal this, essentially, right? No, that's not what I'm saying. I'm saying that, I mean, what this should be is that the 3 should be here, right? So this, right, should equal this, is what I'm saying, right? So if the reverse of the first half does not equal the non-reverse, or whatever which way we do it, then it's not symmetrical. So we could iteratively, I think, do this with a breadth first search. So we can say while q, and of course the first element of the q, the first element of the q should be the root dot, the root, of course. Output should be the first value, of course. While q, if root if it's valid, then we say, so if q, right, we want to essentially say, well, actually, we only add the value, we add the value here, we say output equals root.val, and we have output equals root.val is the first element in the output. Actually, this should probably be up here now. We have our current level, what level we're currently on, its values. If root, or rather, if root, so if it's valid, right? If the root's valid, then we add the right and left. So we say q dot append the root dot left, q dot append root dot right. But if root, or rather if root dot right, if root dot left, append the left. If root dot right, append the right. So there's a current level. If root dot then, we in our queue, so we know that the node equals, or rather, we're at the current level. So for I in range length of q, we extract our node. So we say node equals so for I in range length of q, our node equals qi. Yeah, qi, I think. qi. And then we add it if it has a valid, if that thing in the queue has a valid thing. At the end of the level, well, we need to do, I think, more checks. So this is the current level when we get out the for loop. So we append just to test, I'm just going to quickly append every time we do this the current level, which is an array of arrays. I just want to see if it's doing the right thing. This seems a bit wrong, but hang on a minute. Node.left, node.left, dot right. While q current level equals this, for I in range length of q, node equals qi. If node left, append left. If node right, append right. Output dot append current level. No, sorry. Current. Well, actually, no, that's right. What over here? I need to say current level dot append node dot val. I just want to print output to make sure I'm traversing this right. Output. For I in range, length of q, node equals. Oh wait, sorry. Did I just say fucking? I meant node equals q dot pop left. So 1. What did I feed it? 1, 2, 2, 3, 4, 4, 3. Why is there a 1 at the start? Oh yeah, we don't need this here at the start. Okay. So we correctly level traverse this. So to tell if it's symmetrical, but I want to tell it's symmetrical as I'm going through it, right? Rather than having to store the whole thing. Because like you could tell up here something was not, like for example, this is this level. Let's say this was symmetrical, but then the level below it wasn't, right? You don't want to store the whole traversal. You want to do it earlier. You want to detect it as the first second you see something that's not symmetrical, right? So the idea is that if the current level, right? If we're at current level, we just appended to current level, right? We just appended to current level. So if current level, so if we're appending the current level and everything in the for loop, right? Just outside this for loop, we can say if. So I don't even think we need output here. I don't even think we need this at all. We can just say if the first half, just like what we're saying over here, if the first half of the current level, right, which is the length of, so current level, which is 0 to the length of the current level, the length of the current level divided by 2 equals, so no, yeah, we could just return here. Return this equals, essentially, it needs to be the reverse. So what we're saying is that if this, so okay, there's one, so you remember 3, 0 would have to be for this, the way for this to be symmetrical, right? So we can say that if current level here 0 to thing does not equal the reverse. Actually, does this make sense? Can I do this? But you kind of get what I'm trying to say, right? We're trying to say like return is if the first half does not equal the second half, which is of course length divided by 2 to the end. Then yeah, it should be false or true. Really thought I got that bitch there. Hang on. Let's see. What's the problem with this? Just saying it's true for some reason. It's true. I'm gonna have to print the output just to see. What's going on here. Okay, so instead of returning, I'm just gonna comment that up real quick. Output equals quickly print the output. Wait, what? Now it's saying it's false. Oh yeah, because there's no return. All right. 1, 1, 2, 2, 1, 2, 2, 3, 3. Wait, what? Ah, that's right. because when we're adding the output. Oh, sorry, I'm printing this in here. Yeah, it's because when we're adding this output here, it's 1, 2, 2, 3, 3. It's ignoring the nulls. We need to add the nulls to it. So when we're saying if no dot left, if no dot right, so I think it just doesn't matter, you know, if no dot right. So fuck it, you know, it doesn't matter if it's null or not. Just add it. Just add it regardless. So current of log pen no dot val. So we can just say if node, if not node. Sorry, q dot append left, q dot append right. Well, okay, so hang on. We have a BFS traversal here, but we also need to think about one thing. If we also want to add null, and we can just make our own value and say if it's null, it just add -1 to it, for example. So we can, but the thing is, what if there is -1 to it? So we should add infinity, minus infinity or something like that. So if no dot left, right? If there's a left value, if no dot left, or rather we should say if no dot left, blah blah blah, elif node dot left, elif not node dot left, we want to say q dot append float minus infinity. Just say minus infinity, right? Elif node dot right, do the same thing here. Say elif not node dot right, then q dot append float minus infinity, right? So you've got these two things here, and then the only problem here, you won't have a no dot val, right? So we need to say that if not no dot val, if not no dot val, append. So we append infinity if there's no right. If there is a right, we append the right. If there's no, so when we're checking the node, right? If not no dot val, i.e. if it's float infinity, right? Or rather, if node equals float minus infinity, if it equals that, then we just we continue, right? Else we append the value. So now we should have float infinity in places of null. But no, we get an error because it says that float object has no attribute left. If no dot left, elif not no dot left, append. If, oh yeah, because we oh yeah, you're right. We want to append the null. I want the nulls to be included, right? So if node dot left, elif not node dot left, q dot append float. I have the right idea, but it's a bit off. Elif not node dot left minus float infinity. The values are binary, but of course there is no float infinity dot left. That's the problem because we're appending to q. So in the case here, okay. So I think this needs to happen. I think this needs to happen up here. And we need to say something like node equals pop left. So over here, if node equals, all right, yeah, I think so. If node equals float infinity, skip it, right? Just skip it, and yeah. So we have 1, 2, 2, 3, 3. Come on, baby, work. Fuck. I really thought I had it. I really thought I had it. Oh, of course that returned false because it's fucking. It's fucking. Hang on. Let me see what's output in here. So as you can see, where the heck is this coming from? Where's this bullshit coming from? Ah. As you can see, that will not work because. Nah, yeah, that won't work. That will not work. That will not work because there's the none still being added from that last thing. This idea here is right where equals half of it. Let me see, how did I solve this before? How did I solve this before? Submissions. Did I do the recursive version or the iterative version? I did the recursive version. I don't like the recursive version. Let's see. Root dot right left. Oh yeah. Oh, so basically we're just Oh, I see. So I had a similar idea here. It's just when we're at Q, right? We're appending. Yes, that's the problem. That's my issue. So we're saying something like Q dot append root dot left and root dot right. So we got 2, 2. While Q current level equals whatever it does for I range Q node Q to pop left, right? Actually, wait. Let me see what I did. Discuss. I definitely got the right idea. Just need to practice a bit more. But I'm definitely, at least I'm able to kind of think of something with these questions rather than just completely black out. C++. Actually, probably better solutions now. Let's see. This is it's recursion. I don't like recursion most folks. Let's see. Recursive and iterative. Alright, here we go. I like this guy's solution because it was similar to what I'm trying to do. Yeah, similar to what I'm trying to do. So here, okay, got the typical thing. Q.collection.dq root left, root right. Cool. While Q T1 T2 equals pop left, if not T1 and not T2 continue, which was the what I was saying with my flow infinity thing I was trying to do. And if not 1 or not 2 or T.2 dot value, so then we're saying if not T1 or not T2, if not T1 or not T2, or T1 or return false, and then we add to the queue the left, the right, the left, because that's a metric. Of course, yeah. That's literally essentially what I'm trying to do. As you can see, I mean, when we, you know, oops, I guess we need to get that out of here. I mean, yeah, I'm trying to do something similar. Oh yeah, oops. Actually, why am I even doing that? I can just literally say, yeah, of course, because the subtrees have to be equal. So it's the idea of we have root dot left, root dot right, right? And then we have current level. We got, so really it's the idea of we have, yeah, that makes sense now. You know, tree 2, subtree T1, subtree T2, Q dot pop left. So now we have we have this subtree and this subtree, right, as T1 and T2. So if well, so I mean, yeah, you know, if it's empty, if not root, you want to return true because you know, nothing is symmetrical to nothing. So we can say, if we look at it, actually, we can say if T1, if not T1, so yeah, we can say something like if not T1 or not T2. So if either one of them are whatever, but there could be a case where they're both not, so we have to account for the fact that, well, that won't be the case because over here we're already doing that. No, sorry, if not T1 or not T2, i.e. if, you know, we got a value here and a value here, but also hang on, 2 and 2, pop left, output out a pen, we don't need to do that. If not T1 or not T2, and its value doesn't equal the value return false. We need to add to the queue. We need to add to the queue we need to add to this queue we need to add T1 dot left, T2 dot T1 dot left, T2 dot right, T2 dot right, and then the reverse, T2 dot right, T1 dot left. And okay, and then if we eventually get out of it, then return true. So we have our thing. If T1 pop left, 4 not. So if not, we return true. We got our output. Don't need that. So we have for iron range T1, T2, Q dot Q dot pen T1 dot left. So that's the same like this. Pen this. Append that. Then append right. Then append that. So append the other way around. We can say T1 dot left, T1 dot right, and T2 dot left. So we're appending T1 dot left, T2 dot right. So the idea is that, okay, we're appending this in a symmetrical fashion, and we're saying if not T1 or not T2, and T1 dot value doesn't equal T dot 2 dot value, return false. What other scenarios are there? If the, okay, I mean, yeah, that's good to me. Pop from an empty DQ. Pop from an empty. What do you mean? We have root dot left, root dot right. If not root, return true. While Q. We're supposed to account for something here? Well, what was that guy's solution again? Let me see. Let me check it out. It's very similar to what I was trying to do. I think it's worth learning from. Yeah, there we go. He was saying if, oh yeah, he had this thing here. He was talking about if not T1 and not T2, then continue. Because T1 would be, so because remember that we would have this and this. So if they're both empty, okay, yeah. If not T1 and not T2, continue. And the idea is that we're adding T1, right? As in we're adding the left, the right, the right, the left. So if both the subtrees are empty, right? Then so if you have T1, T actually wait, what? If not T1 and not T2, as in the whole subtree, if the whole subtree is null, just continue. How would that even work? You would have 1, 2, 2, but then wait, what? Pop from an empty DQ. What's the problem here? How is this empty? I'm saying Q equals root dot left and root dot right. Root dot left and root dot right. How is this empty? Wait a minute. If not root return, oh, I should do the check at the start. Oops. Actually, that wouldn't even make sense because this, I know the input is valid. Hang on. Clearly I'm doing something wrong here. While Q, you're saying pop left, pop right. And then if not T1 or not TQ, it says dot append treats all 4 nodes as a single item in this case, a list data type, whereas extend. Oh, I see. Okay, hang on. Oh, so append doesn't work, but plus equals works. Append mutates the object and adds the element. Plus equals extends the object. In this case, you can use q.extend because plus equals will add nodes to the list, while append with add list adds nodes to the list. Append treats all 4 nodes as a single item. In this case, a list data type, whereas extend process 1 item at a time. In this case, for hang on, wait. Append mutates the object and adds the element. So you have 1, 2, 3, and append 1, 2, 3 again. Okay, and plus equals extends the object. Oh, it adds individual items. Okay, so either extender or plus equals works here. So what you mean is we're adding left, right, right, left as individual items, not a whole list. We're still what the fuck is going on here? Q to pop left. What the fuck? Oh, yeah. None type has no attribute value. None type. If not 1 or T2 and not T2 value. It shouldn't even do that. What do you mean? We're saying if not T1 or not T2, continue. It shouldn't even get to that point. What? Oh yes, of course. It's saying continue, as in it will. Actually, no, continue should just. Oh yeah, because we're not in a 4. Oh, yeah. Okay. Wait, what? If not T1 or not, and not T2, continue elif, not T1, turn false. What the fuck? Oh shit, I'm fucking saying and here. Whoops. I want to understand this. This is pretty much what I was trying to do in my head, with my idea of this essentially, and then the flow infinity thing I was doing. So I'm interested. We have our T1 T.2 pop left. If not T1 and not T2, continue. If not T1 and not T2, continue. So it just skips the whole for loop. I mean, skips the whole part of the while loop. I understand that. Yeah, if they're wait. I don't understand why we would continue here, because if you're saying T1 and T2 is originally root left dot right. Okay, so let's say we have 2 and 2, right? We have 2 and 2, which is so originally, of course, if the root is null, then there's no subtrees, right? Return true, because emptiness is symmetric with itself. Then append root dot left and right. So we append 2 and its values and 2 and its values. It's subtrees. We then pop them out. Now their values T1 and T2. Node 1, node 2. But we're saying if they're both null, if these two values were both null, continue. But that doesn't make sense to me, because if these values were both null, right? If these values were both null, what is there to continue to? There would be no subtrees. Okay, whatever. They're not null in this case. So let's move down forward. If not T1 or not T2, as in if either one of these values here, this is null, if this is null or this is null, whatever, if either T1 or not T2, because in the case where they're both whatever, but I don't understand, and what's the purpose of this line over here? Because I don't get it. What's the purpose of that line? I feel like this should just work without asking if or. Right? No? It doesn't work. None type has no attribute. What do you mean? If not T1 or not T2, but I don't understand that, right? You'll have a scenario where if not T1 and not T2, which already should cover that, but you can have a case where literally both, yet again, are not T1 or not T2. But you won't, because if you did, it would just continue. So you'll only have the case, because if you had both, that's already checked first. So that means the other scenario is that only one of these could be null. So what it's saying is that if this is null, or this is null, so sorry, if this is null or this is null, just whatever, or T1 dot value does not equal T dot 2 value. Wait, I'm confusing myself here. You're saying, so you have Q plus, okay, how we're adding the values T1 left, then T dot 2 right, because you add there, then you add T1 dot right, and then T2 dot left. Makes sense, because we're adding in symmetrical fashion. So what we're saying is, because of the way we add it here, so the initial loop does 2 and 2. It says that T1 dot value does not equal, but here it does equal, so we move on to here. So now we have a situation of T1 dot left, right? So we've got T1 dot left, and we have T2 dot right. T2 dot right. So now we have null and 3. This will be the not T1. It's null. So if this is null or not null. So if one of them, so basically it's saying if one of these is null and this is not null, then obviously this is not symmetrical. And if the value, and let's say, and in the case that they're both not null, so let's say this was 4 and this was 3, and they're not equal, then return. Yeah, makes sense. Yeah, I understand that. No need for explaining. Pretty much what I was. Honestly, it is what I was going for. It is what I was going for. I'm still trying to get the syntax, but I'm happy that I was able to like, kind of think of the solution. I just couldn't implement the exact implementation. So it shows that I'm improving. You know, do this for an hour or two a day for a few months. You'll improve a lot. I do want to do one more question. I think it's a solid question. You can see this is why I'm doing the 3 questions I was doing back, because as you can see, I wasn't really focusing on it as hard as I am now. Even though like no one's watching these videos, it allows me to kind of focus a bit more. I feel like it also kind of helps with like, when I have to talk to people in an interview and shit. Give me a second. Damn, people are already out in bars and shit. I was just at home chilling. Okay. Gallons. Grab my Everclear. We got 3 bottles of Everclear here. Good to go. So strong. You can let that sit and then you want to shake this up before you pour it in, okay, guys? Because expect when you drink this to start sweating and breaking out. No. It's not a virus, okay? It's the punch. All right. Now keep watching this, guys. Watch this bottle, guys. Watch this bottle. All right. All right, we'll do another tree question. Let's see what's good here. Binary level order traversal 2. What makes this different? Fuck is this? Given a binary tree, return the bottom up level traversal of the nodes, i.e., from right to left, level by level from root to left. I mean, this is fucking easy. Like, this is just doing normal traversal and reverse. This is just storing the whole thing in output and just reversing the output. Like, it's really not that. Fuck it, I'll do it anyway. We have our output equals. Well, I mean, of course, that requires more memory. Is there a better solution to that? If you think about it, like the obvious solution, just do a normal BFS and reverse the output. But is that the best solution? Probably not. Can you do this as you're doing it? Can you do it as you're doing it? Let's think about it, right? Instead of for looping, what if we pop right instead? Ooh, okay. Can you pop right? Is that a thing? Actually, no. That's just a normal pop. Yeah, I think. Okay. Yeah. I think. Okay. Cool. We have our queue. Contains the first value, the root. We can say while queue This is our current level, and if root dot right q dot append root dot right, if root dot left q dot append root dot left. So here's our current level. Our node equals q dot pop instead of pop left. So when we're popping, so if we're penning to the right, penning to the left. So when we pen the right, you pen the left. So that way when we then pop out, we have 20 and 9. Oh no, you want 9 and 20. Oh, you want the whole thing, like, oh, okay, yeah, shit, then that doesn't even fucking matter. Okay. Let me just pop left in this case then. Oh, so you're telling me you want the whole level, just like, then I just reverse in the list. Like, it's literally just it. It's literally just the answer. So you're saying if root dot right, if root dot left, append. We can't forget the most obvious shit, which is if not root. If not root, return. Let's see. The output is a list of a list. So what the fuck do you want me to return here? You want me to just return essentially? If I just return it, we'll return the default of this, wouldn't it? So then return equals this, q equals this, while q, current level, if root dot right, if root dot left. Current level dot append current level dot append node dot value. So you're saying what you want is, well, we can have it so that we could append this to another queue, right? Couldn't we? We could append this to another queue, or let's say current level was another queue, and you can say, yeah, okay, yeah. I mean, if you appended current level, let's say current level was another queue, you append it to it, so that way you'd have 3, 9, 20, 15, 7, but then you for loop through the current level queue, but backwards. But either way, it needs to be a list of a list, so you still have to put this into something. I don't think it changes either way. Either way I do it. Hang on, let's just get the version I have in my hand done first. So we have output, we have a queue, we have current level dot append dot node value. Then we append to the output the current level. So sorry, we have current level node dot dean. If current level dot append. Yeah, current level dot append. But of course we want to store it. So for I in range length of q. So we want to store the value. That's the difference here, right? Oops. So we have to say for I in range length of q if root dot dean. Oh, for fuck's sake. Like I said, we want to store the value, right? Output dot append. So really, just an idea of you print output. Sorry, you return output, but reversed. DQ is not defined. Deck is not defined. Deck. Am I spelling this right? 7.5. Oh wait, the fuck? The value itself is. Wait, what do you mean? 15.7. Why? What? Wait, what? Append right first, then append. Oh, whoops. Should be append and left first. Q dot append left. left, Q dot append right, Q right dot append right, Q append right, right current level. All right, this should be okay. Yeah, makes sense. Makes sense. Let me go check if there's a better way. Actually, before I even do that, let me check. Let me think. Is there a better way of doing this? Is there a way to do this without? Well, actually, not really. You need to store the fucking values, right? But can you make the list of lists without having without having to do the reverse operation? Can we just add it in a certain way? If we think about it, right? If we're added in 3 first, then 9 and 20, then 15 and 7, we could just say, if this is the current level, right? And instead of appending, if output was if output was a Q, no, that wouldn't. I mean, if we appended it, right, we have output, but it's this in reverse. If we added 3 originally, then add 920. Can we append to the left? Can you append to a left of an array? Append left Python array. Is that a thing? Is that a thing you could do? Appending to the beginning of the list. Can you say that? Is that like a thing? Insert. Insert happens in place. So you could say, what? Insert at 0 the current level. So that way you don't even have to do an ON operation to reverse. You just do an O1 insertion and then return the output. Yeah, I think that's a lot better. I think this is a faster solution. Yeah, makes sense. Makes sense. We do an operation and return the output. Yeah, even faster. So, yeah, let me check the discuss panel, see if anyone did anything. See if anyone did anything better. Deviance plus Q. No. I realize people love to do. I realize people, the way they like doing it is without the for loop. So they like to. So look at this music cue. I can't. People like to. Got root 0. Pop left. So yeah, people like to do that. So it's just if length of the result is less than level plus 1, insert 0. I don't know what this man's doing here. Oh, he's doing a no, he's not. He's just appending the queue, then appending the level. Why is he appending the level? Why would you need to do that? Append the level. You want to append the level. Why would you want to append the level? What do you get out of that? What do you get out of that? Level plus 1. Q dot append level plus 1. Where level is 0, then it's added in. Yeah, see the complexity of insert is ON. Well, it depends how you insert it though. Depends how you insert it. You see, if you insert it the way I did it, then it's O1. It's not just. Let me see if anyone mentioned that. How is he inserting it here? How is hardly insertion is not ON if you're inserting it at the start. What? Isn't insertion O1 if it's just inserted at index 0 each time? Hang on. Insert 0 index Python time complexity. Insert at the 0th index is however, if you use it, insert at the 0th index of a list requires shift in every element. Oh, elements have to shift. Of course. So if you use a DQ operation, append is amortized O1 operation since it simply requires adding the item onto the end of it and no shifting is done. If you use a if you use a DQ, this operation is O1. The operation is O1. The append is amortized. If you use simply requires adding the item. If you use a deck operation, we've only been recording for an hour 11 minutes. Feels longer for some reason. However, if you use a deck operation, it's O1. What does DQ? Deck Python. Deck Python. Deck DQ Python. DQ Python. Let's see, what other operations we got? Clear, insert. Pop remove it. Extend left, rotate, extend. Oh, okay. So what did he do then? All the fuck was he doing there? This guy has 78,000 points. Holy shit, man. Chinese people just be fucking Chinese people, man. These dudes just be Asians just be they just be fucking algorithm away. God damn, since like fucking birth. Hang on. What's this deck operation? Today's Saturday, right? I mean Sunday. Yeah. Thought for a second it was Monday. Oh, so he did the same thing I did. Okay. But isn't reversing also an ON operation? What? What are you talking about? How does this make this any faster? Wait, what? Time complexity of Python. What is the time complexity? You can see I've clicked this before. In C Python, assume arrays a list, the expression blah blah blah. Both time and complexity are ON. Yes, I expect it to be ON. I really do expect it to be ON. Wait, what did he even change here? Yeah, he got rid of the assertion, but this doesn't make it any faster. What? What? That doesn't make it any faster. That doesn't make it any faster. What? What? My approach is to use a deck without using level. I don't understand what he did is any faster. Like, cause reverse in the end, just like I did originally, doesn't change anything. His solution is say -2. So, what does he do? His solution is he has a queue. Well, it's not really a queue; it's just a list. He has a list where q equals, so he goes for child in node left and node right. So we go through left first. So he goes for the node for child. If node for child in queue. Bro, like, honestly, I hate when niggas type list comprehensions like this. Like, what the fuck is this? Like, this is not instantly readable. Like, okay, for child in node left dot node right. Okay, then if node for child, then for node in queue, I hate niggas that write list comprehensions like that, man. For fuck's sake. Like, fuck off with that bullshit, man. List comprehensions just be if they're simple and small, not that fucking shit. Jesus Christ. Niggas just going crazy, man. I don't even understand this guy's solution with this whole level bullshit. Like, why would you say if the length of the result is less than the level plus 1? What are you talking about here? What is man's talking about? I just want to see what's the fast. I just want to see is there a faster solution? Is what I'm asking here. Does anyone have a faster solution? That's all I want to know. Add easy to. Okay. Yeah. What's he doing here? He has a result. If not, return result to stack. Why? Why do motherfuckers do this? Like, it just looks ugly. Stack. You just add a fucking extra line, man. Stack.append root and count. Motherfuckers who type Python and then type camel case. That pisses me off too, man. Like, keep Python with snake case. Thank you. While stack. Node equals stack.pop. 0 element. Data plus equals node.value. I don't know why those people are doing count and stuff. I don't understand. But you know what? It doesn't matter if I understand their solution. The point is, I understand my solution, which was just reversing the bullshit. So I'm happy with my solution. I don't see how it could be done faster. You have to store the whole thing. You have to store the whole thing anyway, right? So it's like, you know, what's the difference? Like, you know what I'm saying to you? You know what I'm saying to you? That doesn't really change anything. You have to store the whole thing anyway, right? Like, there's no real way to do it. I'm getting fast runtime, so I think it's pretty good. Yeah, it looks good to me. But I am interested. Why did this Daily guy use the reverse? I don't understand. He said to the other dude that fucking, you can see other people have done it as well. I don't know what that Lee guy is saying. Actually, let me look at the comments of what he was talking about, because I don't understand why Mans was talking about. He changed dude's insertion to a reversed list, but it doesn't change anything. What? I don't understand. It literally changed nothing. You're still the same time complexity. No? Am I wrong? Let's see. You need to store null node in the queue. No need to store null node. I'm talking about you could use if child and eliminate. Genuinely, when I see motherfuckers, right, list comprehensions like this for x in L dot left and L dot right. Now, okay, you're calling it Q, right? And now you're saying L and Q, X for L. Let's just fuck off, man. Honestly, fuck off with that bullshit. The one same idea with that reverse at the end. Now this is what I'm talking about. This is what I'm talking about. This guy goes node level if length of traversal equals. Why would you call it that, my guy? Does no one know how to make fucking good variable names? What the fuck? Tra. What the heck is tra? Why would you even call it traversal? I'm assuming that's what you're calling it. Whatever. Anyway, if the length of the traversal equals the length equals level minus 1, append left. Oh, there is an append left. You motherfucker. You bitch. If no left, append. Why? I don't understand why people are appending. What's this level business about? What's this level business about? I don't understand. Why are people appending levels? What? So you know the position of the place. So you're saying that if the length of the traversal equals level minus 1, what the fuck does that even mean? Do you mean if, for example, you're on level 1 and if level equals length of traversal? Why are people doing this? If the level equals the length of result, so this is result. What the fuck? What the fuck? I don't understand why people are doing this level shit. I genuinely don't get it. I need someone to explain. Also, when people say amortize, what the fuck does that even mean? What the fuck does this shit mean? To reduce. What the fuck? Hang on. Yeah. The approach to use deck without using level. Deck without using level. I genuinely want to know why people are appending the level. Why would you? I don't understand. I want to understand why people are doing this. Like, why would you carry the level? I just don't get it. I just don't get it. What would you do with the level? Where's that guy who didn't use didn't return the reverse? Where is he? Oh yeah, here we go. I'm gonna understand it. He's saying, okay, he has two Q's, right? And deck equals dot append. He really called the Q deck. Okay. Root. What are these variable names, my guy? What the fuck? You're calling it deck? Okay, whatever. Deck dot append root 1. Okay, so we start at the first level. While deck node level equals then if the length of the traversal, if the length of tra equals level minus 1, so if 0 equals 0, is that what you're saying here? Then append left. Append an empty list? What? Then you're saying index into level minus 1 plus 1. Will you not just say level? What? Minus the level. Why are you saying minus 1 plus 1 here? You're just saying level here. So minus level, append no dot value. So if the level here is, so what he's saying is, he's saying the first thing is level 1. So he's saying that 1, append the value to minus level. This level 1 is level 2. This was 2. This is 3. Then you're saying that's what he's saying anyway. He's saying take -3. See the level -1 plus 1. Okay, 3 -3 without a pen the value. So what you're saying is you have your list of lists. This is 0, 1, 2. This is level 2, right? What you're saying is record the level and then pin it to the start. Oh, yeah, I get it. I get it. Yeah, I get it. All right, I think that's good. Spend an hour and a half on these two questions. I think I'm getting better at these binary tree easy problems. We're gonna do 2 more later today, or maybe 3. Probably do 3 more later today. And then maybe move on. Maybe spend next week looking at the medium questions. We can still do what are we even done here? We can do lowest common ancestor. We can do maximum distance. Yeah, we'll do these 2 later. Yeah, I think that's good for today. I mean, good for now anyway. Yeah, cool.